Hey guys, here's the second part of the test review. Question number 6. Select all of the following that prove that ABCD is a rhombus. So if we look at our cheat sheet, we know that a rhombus, thank you, it's supposed to have all congruent sides. Wow, that's thick. Let's thin it up a little bit. All congruent sides. Cool. A couple other things about a rhombus. Rhombus can have perpendicular diagonals. A rhombus will have diagonals that bisect each other. So we could do stuff with the diagonals too, but we're going to use this all congruent sides, and we're going to go from that. So if we played the game, what formula will we use? You know that we would be using the distance formula. And you know that I don't really like the distance formula, so I'm going to use Pythagorean Theorem because it's faster and way more fun. There. All right, so to use Pythagorean Theorem, that means I have to count the rise and run from point A to point B. So from point A, see its coordinates here, it's kind of a really crummy graph, but I know that I'm going up one square and over a certain amount. Let's see how many I'm going over. I'm going over 1, 2, 3, 4, 5, 6, 7. So I'm going up 1 and over 7. So, and the cool thing is I'm not really even going to do Pythagorean Theorem. I'm just going to make sure that all of it, well, I guess I can do it really fast. Watch. 1 squared plus 7 squared equals c squared. 1 plus 49 equals c squared. 50 equals c squared. So c equals the square root of 50. And we could, if we were really, really good, we could simplify that and say that it's 5 square roots of 2. So either one is good. This is the goodest, though. All right, and then I can count the rise and run of DC to see if it matches. D to C goes up 1 and over a lot. Let's count them. Ooh, it's really hard. This graph's tough. 1, 2, 3, 4, 5, 6, 7. So this graph's kind of tricky. It's hard to see the points. But yeah, it goes up 1 and over 7. So if I were to do Pythagorean Theorem, I know that it would match. So I do know that AB is congruent to DC. True story. So I need to check out the other sides too, though. I got to check out AD and BC. So let's check out their rise and run. So I'm going to make the same little slope triangle things. And we're going from A to D. Try to make my line straight. So I went down 1 unit, 2 units, 3 units, 4 units, 5. I went down 5 and I went over 1, 2, 3, 4, 5, and over 5. So you could use a shortcut because you know something about a triangle that has sides of 5 and 5. You know that the hypotenuse is going to be 5 square root of 2. Oh, that matches our other one. So if you didn't remember that shortcut about special right triangles, then you could always just do the Pythagorean Theorem, and Pythagorean Theorem would say -5 squared plus a +5 squared equals c squared. So 25 plus 25 equals c squared. Hey, that's a 50 equals c squared, square root both sides, and c equals the square root of 50, which we could simplify to be 5 square root of 2. So you do see that this side, which is called AD, is congruent to those guys as well. So everybody is square root of 50. Everybody is a 5 times square root of 2. So we have one last side to check. That's BC. So I've got to make my slope triangle going from B to C. So let's see what I do here. So from this point, I went down 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5. So again, this rise and run is going to match with AD's rise and run. So I'm not going to waste time doing Pythagorean theorem or distance formula because I know that they already match. Same rise and run, then we done. There's a new saying for you. So BC is going to be congruent as well. So all those sides are congruent, which means that this is a rhombus. So if I had to choose from these answer choices, all sides are congruent with a length of 5 square root of 2. That's true. The slope of AB equals the slope of DC. Hey, that's true, but that's not why it's a rhombus. We want, why is it a rhombus? Because all the sides are congruent. The slope of AB equals the slope of D. That doesn't even make sense. The slope of D? What? I think that's probably a typo. Opposite sides are congruent. Okay, so the opposite sides were congruent, but DC and AB were not 4 radical 3. So that's just wrong. The slope of AD equals the slope of BC. That doesn't make sense either. And they both have a slope of -1. Well, they might. Actually, they probably do. Yeah, they do. True, but that doesn't prove that it's a rhombus. That proves that it's a parallelogram. So I'm going to write proves, or actually that only proves that one pair of sides is parallel. Proves that one pair of sides is parallel. So I'm not even going to pick that as an answer. I'm only going with the first choice here, this guy. Because that directly proves, hey, it's a rhombus. And it's true. Wow. That's question number 6. We have a lot to do. Let's go. ABCD maps out Xavier's running route. He runs in a perfect parallelogram. Wow. If he does one complete loop, how far will he run? Each square unit represents 1 mile. So each unit represents a mile. So I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So he runs 13 units going that way. That means he's probably running 13 units going this way. But these crooked parts. So there's where we could play another round of what formula will I use? The funnest game ever. So let's just do one side, and I bet the other side's going to match because it's a parallelogram. So I'm going to draw my little rise and run slope triangle here. And I'm going up. Looks like I'm going up 1, 2, 3, 4, 5, 6, 7. Looks like I'm going up 7 and over 1, 2. So if I wanted to figure out this part of Xavier's trip, which is on both sides here, I would use Pythagorean Theorem. So if you saw a question like this on the test, and it said, which formula will you use? You would say, I want to be a good little robot student and use the distance formula. But you know better. You know it's easier to use Pythag. Pythagorean Theorem. So instead of busting out the distance formula that I always forget, I'm going to say, hey, 7 squared plus 2 squared equals my distance squared. So 49 plus 4 equals c squared. All right. So square root of 53. And that's a gross number. So square root of 53 and square root of 53 on both sides. So I'll have to bust out my calculator because I'll have to pick the answer that's closest to his route. So on one side he runs 13 miles. 13 miles? This guy's crazy. On the other side, he runs another 13 miles. And on the two ends, he's running the square root of 53 miles. So my calculator, I'm using my phone. So I'm going to turn it sideways to do square root of 53. 53 square root. And that's 7.28. So he does that twice. So I'm going to add up 2 of those or multiply it by 2. So that's 14.56. And then the 2 13s. So I'm going to add 13 there twice. All right. And he runs 40.56 miles. So the closest answer would be 41 miles. All right, this is the exact same parallelogram that we just looked at. So I already know that this base is 13, and they want the area of it. The area equals base times height. And the height, I bet you remember, runs perpendicular, makes a 90-degree angle with the base. So the height there is going to be a 1, a 2, a 3, a 4, a 5, a 6, a 7. So I'm just counting the units from the graph. So the area equals the base, which is 13 because I counted the units on the graph, and the height is 7, and it had to be perpendicular to that base. So 7 times 13, which is 91. So the area of that parallelogram is 91 square units. There it is. Beautiful. All right, on this one, it definitely helps to graph it. So I stole a graph from the interweb. And you guys should totally use graph paper if you have it. If you don't have it, then ask me and I'll get you some. So I'm going to draw this graph real quick. And I see some negatives in there. So I'm going to put my axes. Let's see. Let's try this. See if I can fit all this on here. It goes up to that. Let's see. All right, that should fit everything. Okay, so Q is at negative 8, 0, negative 1, 2, 3, 4, 5, 6, 7, 8. It's negative 8, 0. I'll put point Q here. 0, 6. So 0. Oh no, I didn't make my graph big enough. Darn. I can fix that. All right, try it again. Q is at negative 8, 0, negative 1, 2, 3, 4, 5, 6, 7, 8, 0. So there's Q. U is at 0, 6, so 0, 1, 2, 3, 4, 5, 6. A is at 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. And D is at 0, negative 15. So 0, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to run out of room. 13, 14, 15. Wow. All right, so there's my quadrilateral named quad. And you guys know what that looks like. It looks like a kite. So it looks like a kite, and in fact, the way it's graphed, you can even tell that it is a kite because I see those crossbars, the diagonals of the kite, and they're perpendicular, and one pair of them is bisected. So there's a lot of good stuff going on here. So quad is a kite. Filling in the blanks because it has exactly 2 pairs of consecutive blank sides and its diagonals are blank. So its diagonals are perpendicular. That's the first thing I noticed. The diagonals were making a 90-degree angle. Diagonals go from one vertex to a non-adjacent vertex. So you would have to connect to D. And Q would have to connect to the one that it's not already connected to, which is A over here. So the diagonals do make a 90-degree angle, which means they're perpendicular. Now, the other thing going on here is they have exactly two pairs of consecutive blank sides. So we've got to know something about the consecutive sides. Take a look at QU and UA. And you can tell just by looking, that those things are congruent to each other. QU and UA are congruent. And same thing, if we look at the other pair of consecutive sides, QD and AD, just take a look at them and you know. You don't have to be a rocket surgeon to know this. You can tell that they're congruent as well. In fact, it looks like that triangle is a reflection. If you reflected it over the y-axis, it would lay right on top of the other triangle. So I know two pairs of consecutive congruent sides. Matching, congruent, equal. Bam. It's a kite. Ooh, we're back. So we're looking for the perimeter and the area. I'm going to start with the area first because the area of a kite is really, really easy. The area of a kite is just 1/2 of one of the diagonals multiplied by the other diagonal. So 1/2 of D1 times D2. So make sure you know how to count. That's the hardest part. Diagonal 1, let's make diagonal 1 the side to side, the horizontal one. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So diagonal 1 is 16 units. You could have known that because this was, Q was 8 units to the left and A was 8 units to the right. 16. Now I'm going to take a shortcut here. I know that the distance from U to D is going to be 21 units. I didn't count it. I just knew that U was 6 units up and D was 15 units down. So I'm not going to waste your time counting. I'm just going to let you know it's 21. You can count it if you want. So I have all the missing pieces filled in. And I'm going to my calculator and I'm doing 1/2 multiplied by 16 multiplied by 21. And I got 168 square units. There you go. If you guys get really good at this, then you can come over to my house and help me tile my bathroom. And you can tell me exactly how many tiles I need because you'll know how to find the area. And if you do it for free, I'll give you an A. What was the other thing we're trying to do? Area and perimeter. So we've got to find the perimeter, which is the distance all around. So we'll need to find all the side lengths. That's going to be kind of easy because I already have all these, I already have all the rise and runs figured out. So I know that this piece of the triangle, QD, I know I have an 8 here and this is 15 units down here. So I can use Pythagorean Theorem to find QD because QD squared is equal to 8 squared plus 15 squared. What's 15 squared? 225. All right, so 225 plus 65 equals 289. So QD squared equals 289, and I think that's going to be a perfect square. So I'm going to turn my phone sideways and hit the square root button, and it's 17. Hey, QD squared, sorry, just regular old QD, after I square rooted the 289, QD 17. And if QD is 17, DA is 17. All right, I'm going to do the same thing and find QU up here. I know that this leg of this right triangle that I see is 8, and this leg is 6. So I'm going to use Pythagorean Theorem. Oh, I can do this one in my head. I see an 8. I see a 6. I know that this one's going to be 10. So you can do Pythagorean Theorem, and you'll get 10. the other side's going to match. So the perimeter is the sum of the sides. By sum, I mean adding them up. Not it's like, hey, sum of them. No, it's the sum. So it's 10 plus 10 plus 17 plus 17. What's that? 34, 54. And it's 54 units. It's linear units. It's like I'm walking around with a tape measure. So it's not units squared. It's like a straight line measurement. Okay? So there's question, that was the answer to question 10. So that's all of them. We did question 6 through 10. Yay. It's a kite. Last up, oh, it's the same kite. I want my picture from the last one. I want to go back to the last one. Man. So the perimeter of the quad and the area of the quad. So I'm going to go back to my work from the last problem. So jump back with me, and we're looking for the perimeter and the area. So here we go.